Hey Ario, welcome back to the channel. So today we'll have a look at the book The Embodied Mind. The book is from 1991 and it's considered a classic in the field of cognitive science. And we'll be looking at a revised edition from 2016. The links are in the description box. What questions does the book answer? Some of the questions that get addressed are: what are the origins of the mind and consciousness? How should we think about cognition and perception? How does the body influence cognition? And how can we reconcile subjective experience and scientific investigation? To start us off, let me give you a bit of context. Neuroscience is a rapidly evolving field, and scientific opinions vary among researchers. Some researchers emphasize the role of neural representations and processes with regards to explaining conscious experience, and others consider additional factors to play a role, such as the integration of information across brain regions or the relationship between consciousness and physical processes in the brain. The Embodied Mind highlights the importance of the relationship between mind, body, and the environment in cognitive science. It suggests that our experience of the world is not just about mental representations, but that it is deeply shaped by our bodies, our actions, and the cultural context that we live in. The authors drew on insights from phenomenology, cognitive science, and Buddhist philosophy to argue for an embodied approach to understanding the mind. They proposed that cognition is not merely a process that occurs in the brain, but that it is intricately linked to the body and its interactions with the environment. This perspective changed traditional views that often focused solely on the brain as the seat of cognition. So mindfulness and Buddhist philosophy contribute to the book. The authors offer practical applications and philosophical perspectives that provide additional lenses to which to explore the topic of cognition. So in order to give you a glimpse into the contents of the book, let's take a closer look at Chapter 5. Chapter 5 is titled Emergent Properties and Connectionism. The chapter contrasts two alternative viewpoints in neuroscience: Cognitism on the one hand and Connectionism on the other. To understand how Connectionism differs from Cognitivism, let's first define Cognitivism. Cognitivism likens mental functions such as perception, memory, and problem solving to computer operations, which process information using symbolic representations and algorithms. Cognitivism was successful in explaining parts of cognition, but it encountered difficulties when dealing with topics such as parallel processing, learning, and pattern recognition. There are two commonly known shortcomings of cognitivism. First, symbolic information processing is based on sequential rules applied one at a time. And second, symbolic processing is localized, meaning the loss or malfunction of any part of the symbols or rules of the system result in a serious malfunction. According to the authors, there are three arguments for why the computational paradigm isn't the answer. First, brains appear to function on the basis of dispersed connectivity. Second, experience changes the way brain networks are connected. And third, neural networks can adapt to new situations in a way that can't be explained by a single computing model. So in response to those limits of cognitivism, Connectionism evolved. So let's take a look at Connectionism next. Connectionism focuses on neural network models. It doesn't reject all aspects of cognitivism, but offers an alternative approach that emphasizes distributed processing and learning via the adjustment of connections between neurons. So while each component of neurons operates only in its local environment, there is a global cooperation that spontaneously emerges from the system. So in such a system, there is no need for a central processing unit to guide the entire operation. We can oversimplify connectionism in the statement, networks of neurons give rise to new properties. Some of the cognitive capacities that connectionism is able to explain are rapid recognition, associative memory, and categorical generalization. It became increasingly clear to neuroscientists that they needed to investigate neurons as members of vast groups. Every neuron has multiple and changing responses in a context-dependent manner. So, to return to the original question, what is connectionism? We could state, connectionism considers cognitive processes to be the emergent result of interconnected networks of simple processing units. It emphasizes distributed representation, parallel processing, and learning through the adjustment of connection strengths. Connectivism holds that symbolic processing is simply a restricted and highly specialized subset of cognition. It challenges that symbolic processing is the only or primary form of cognition, and it allows for greater variety of cognitive domains, including mental states, emerging from parallel distributed processing. So now that we defined cognitivism and connectionism and how they vary, let's turn to the last part of this chapter. Here the authors seek to link symbolic computation with symbolic emergence. Both approaches, according to the authors, are complementary, and they see it as a hybrid of bottom-up to top-down approaches. So it is an interplay of symbols and the distributed environments that they are embedded in. Take DNA, for example. According to the emergentist view, DNA triplets are capable of predictably specifying an amino acid in a protein, which represents the bottom-up bit. But they can only do so when they're embedded in the cell's metabolism, which represents the top-down bit. So instead of regarding DNA sequences as independent instruction codes for amino acids to then emerge, DNA sequences can only code for amino acids if they're embedded and viewed as part of an overall regulatory network. Chapter 5 says that our understanding of symbols and cognition is enriched when we consider both the detailed building blocks like DNA triplets and the broader context, like a cell's metabolism. It's like understanding a recipe not by just looking at the ingredients, but also by appreciating how they interact and contribute to the overall flavor. It teaches us to see the interconnectedness of things, realizing that meaning emerges not just from individual elements, but from their relationships within a larger context. The book is a must-read for anyone interested in the inner workings of the human mind and cognition. It's considered a classic, so you should read it. Basically, it's for people interested in philosophy, psychology, and neuroscience. Those curious about mindfulness and its implications for cognition will find valuable insights as well, as will individuals interested in bridging Eastern and Western philosophical traditions. The book uses fairly accessible language, which makes it suitable for a broad audience. So that was it for today. If you found this video helpful, please give it a thumbs up, and I'll see you next time. Bye bye.